So the first thing I'd kind of like to get down on this is something that we just used in the last lesson, which was opposite reciprocal. So let's just make sure we've got some notes on this. Also, parallel lines. What can you tell me about the slopes of parallel lines? Yeah, they are the same. That's right. Parallel lines have equal slopes. Let's say the same. Yeah, parallel lines have the same slope. Always. There's no exception to that. They always have the same slope. How about perpendicular lines? Opposite reciprocal slope. So perpendicular lines have opposite reciprocal slopes. And by opposite, we mean plus to minus and vice versa. And reciprocal, fraction A over B to B over A, slopes. Or flip the fraction, change the sign. Flip the fraction, change the sign. Okay, so we've gotten some practice on that already. Now we have it in our notes. Let's talk about symbols. We've seen some of these so far, and that's been something that, thank you, no, thank you, that we need to get squared away, because I'm afraid you're going to keep seeing them and maybe you won't know. So in geometry, a point in space, say, is represented by a capital letter. Point A, point D. Sometimes we've run across primes, right? So let's say, you know, any letter, A, D, Z, whatever. Sometimes we have translations where we've moved the point. A translation of a point is some sort of movement. You're sliding it, you're flipping it, you're reflecting it. The translation of a point is represented by primes. So if I'm moving A, the new point is A prime. This little mark means prime. If I'm moving D somehow, then I mark that as D prime. And you can have double primes, triple primes, quadruple primes. However many times you're moving the point defines how many primes we have. Are you bringing me work? Okay, cool, thanks. So, we've got points are our capital letters, and sometimes we move them and we use these prime marks. Right, what about lines? Lines are represented a few different ways. How many points does it take to make a line? Right, 2 points to make a line. Two points define a line. So we actually have to have 2 capital letters to define the line. But we have a few different lines. We have segments. A segment is a line that has ending points at both ends. So a segment might look like this. I'm going from this point to this point. Okay, let's call this point A and call this point B. But the notation that you would see in a question would look like this. AB with a little mark above them. Now, when we're referencing a line in space like this, the way we reference it does not indicate direction at all. It doesn't say if it's going diagonally or vertically or horizontally or what. It's just saying starting with point A going to point B, and there's an end at both places, right? It only goes from A to B. Okay. And we usually mark these alphabetically. The next thing is array. Array is a little bit different. Where a segment has a starting point and an ending point, array has a starting point. Let's call it, I don't know, somebody pick a letter for me. A? I like J. I thought I heard J. J's different. J to where? Q? Okay, JQ. So we've got ray JQ. Now here's the thing. The ray starts at J. It goes through point Q and keeps going forever. Like a ray of sunshine. It starts at the sun and comes out and goes on forever unless it hits your eyeball, then that's the end. It becomes a segment, right? If it hits the ground, that's a segment. But if it keeps traveling on past Earth through space forever and ever, that's a ray. And so we would do something like this. JQ. It would start here and just draw an arrow. So again, this doesn't indicate direction at all. It just says that it starts at J and goes through Q and keeps on going. This is a ray. The last thing is a line. A line is theoretical. We can kind of think about what a ray does, but even anytime we deal with infinity, that starts to boggle the mind a little bit, the human mind. But a line is theoretical. A line works like this. It goes through 2 points. Somebody give me 2 letters. M and W, okay? Oh yeah, sorry. Thank you. Yeah. So the line goes through those 2, but it also continues on past in both directions. So it's infinite in both directions. But it goes through MW. And so we would see this as the notation MW with a line on top with arrows in both directions. So these are the notations for a segment, a ray, and a line. Now, so often when we talk about lines, we're really talking about segments. Okay? All right. I think, let me peek at something real quick, but I think that gets us where I want to be for today. Oh, no, there's something else we need to look at. Shapes. Let's talk about shapes. We'll call these regular shapes. Regular shapes have equal interior angles and equal sides. All sides and all interior angles are equal. And we mark things special. So there's some notation here that we'll sort of include into here. So let's start with a triangle. Specifically a regular triangle. These are all be regular shapes today. So that's going to look like something like this. So what makes a regular triangle? 3 equal sides, 3 equal angles. How we mark the angles to be equal is like this. It's a little like crescent moony shape. It's actually called a, sorry, yes?
How could it have all equal sides and not all equal angles?
It can't. It can't. Yeah, by definition, an equilateral triangle is going to have all equal sides and all equal angles. Yeah, yeah. A shape can't be regular without having both. So what these little markings here mean is that all sides are the same length. These little tick marks. What these little, what do you call it, part of a circle? I'm blanking the term. You guys probably can't help me out, can you? Darn it, you can't bail me out. These little crescents of a circle, parts of a circle. Yeah, it's like a semicircle. Yeah. There's another word for it that I'm blanking. But anyway, these little parts of a circle, that indicates that the angles are equal. So this is an equilateral triangle. What if I have a shape that looks like this? What do we call it? Where all angles and all sides are equal. And by the way, what would the angles be on this shape? Yeah. What do we call this shape? Square. Good. It's a four-sided shape where all sides and all angles are equal. I'm going to do the best I can to draw this. Five-sided shape where all sides, or just a five-sided shape in general. What do we call a five-sided shape? Pentagon. Pentagon, yeah. This is a regular pentagon. All sides and all angles are equal, which makes it regular. This is a regular four-sided shape, a square. there's lots of four-sided shapes, right? Rectangles, parallelograms, all sorts of stuff, quadrilaterals. What if I have 6 sides? Pretend that I could actually draw. Yeah, it's called a hexagon. All angles and all sides are equal. Seven sides.
Septagon.
Septagon. You're right. How'd you know that?
I kind of guessed.
Really?
Like I knew it was one of them. I kind of thought it was seven.
It's good guess. Okay, I'm going to quit drawing at this point because I don't know how I would draw a 7-sided equal. 7-sided regular shape, that's going to be a septagon. Again, it's a little easier to draw, but the next one has 4 sides that are the same. I'm sorry, not 4, 8. Hexagon?
No.
Octagon. Octagon.
Isn't it decigon thing or decagon?
Yes, it is. Octagon. How about 9-sided?
Hecta.
No, it's not hecta. You probably don't know this one. What's that? It is a nonagon. Yeah. Nonagon is 9-sided. 10-sided? Decagon. Yeah. All right. So I've quit drawing the shapes, but these are the names. You will, unless the test changes, which I don't think it will, you will need to know the names of these shapes. I don't think you have to know anything past a decagon. And you probably know all of them except maybe septagon. Now you know septagon and now you know nonagon. But my guess is you've heard the others, right? That would be my guess. Okay. All right. That's good for our notes at this point. We're going to take some other notes, but I'm going to hand something out to you first.